Hello and welcome to a lesson on applications of percent problems. So in the previous topic we talked about solving basic percent problems. And we're going to do something similar with these first three examples. What we have to do though is boil down a word problem into one of those basic type of problems. Excuse me, microphone issues here. So what we want to do as a general strategy is read through our problem and then try to restate it in similar terms, but less terms. Restate it into something that feels more like what we were dealing with in the previous topic. And then we want it to be something that we can translate into an equation. So when we restate the problem, let's restate it in a way that allows us to translate into an equation that we can solve. And let's make sure that when we solve, we get an answer that makes sense. Okay? For example, it says, a Yahoo question of the week asked, at what age do you consider someone old? And out of 3,496 people who responded, 1,017 said age 80 is old. So what percent of respondents believe that age 80 is old? So what percent of respondents? What percent of... this is the question right here, right? What percent of, it says respondents. Well, we know there were 3,496 people who responded. Those are our respondents. So if I was restating this, this is saying what percent of the 3,496 respondents believe believe that age 80 is old. Now, the ones that believe age 80 is old, actually we have a number for that too. So this believing that age 80 is old, that's these 1,017 people. So what percent of 3,496 is 1,017 is our question. Okay? So if we translate this now into an equation, what is n? Percent means out of 100. Of means multiply. 3,496 is 1,017. And so, remember what we said last time, right? When I'm multiplying n over 100 by this 3,496, it's really over 1. So it's 3,496 over 100 on this side of the equation. So 3,496 out of 100, oops, this was an n here, out of 100 is equal to 1,017. So if I want to solve for n, I'm going to multiply both sides by 100. It's going to make that go away. And I'm going to have 3,496 n equal to 1,700, also known as 101,700. And now I'm going to get rid of that 3,496. So I'm going to divide both sides by 3,496. And so that cancels and leaves me n equal to, I'm not trying to do that in my head, 101,700 divided by 3,496. So we end up with 29.09-ish. So we're going to say about 29.1%. So there is our answer. And I realize some of you that have a stronger number sense or maybe have more experience with these problems could probably have figured that out in a much simpler way. If you understand what you're doing here, by all means, you do not have to use the process I'm showing you, but sometimes these are hard. Okay, so if you get stuck on one, then try to work yourself through the process. All right, let's try another one. 84% of the schools in the United States have transitioned to online classes. If there are 1,200 schools in Arizona, how many of them have transitioned to online classes? So 84% of schools have transitioned. We have 1,200 total here. So this question is really saying, what is 84% of the 1,200 schools here that we have in Arizona? Okay, 84% of schools have transitioned to online. We have 1,200 schools. So what is 84% of our 1,200 schools in Arizona? So now that we have the restated question, what is our unknown? Is our equal? 84% is 84 out of 100. Of means multiply, and then 1,200. And this one we don't even have to solve. This is a calculator problem because n is already by itself. So 84 out of 100 multiplied by 1,200 is 1,008. So of the 1,200 schools, 1,008 of them have transitioned to online classes, according to this problem, which I completely made up. So don't take that for what it is. Okay, last one here on the front says Melissa wishes to buy a house for $287,000. To obtain a mortgage, which is a fancy name for a home loan, she needs to pay 20% of the selling price as a down payment. Determine the amount of Melissa's down payment. So we have to figure out what her down payment is, and her down payment will be 20% of the selling price, which is $287,000. So the question here really is, what is 20% of that selling price, which was $287,000? That's the question. That's how much she's going to have to pay for her down payment. So again, let's translate this. What is our question? Is our equals. 20% is 20 out of 100 of, let's multiply by, $287,000. Again, don't even have to solve. This one is all set up for us. So 20 out of 100 multiplied by $287,000. So if Melissa wants to buy this house, she's going to have to come up with a lot of money. That's actually a pretty standard amount for a down payment. So $57,400 down is what she needs. Yikes. Okay, it just sounds like a lot when they're coming up with that kind of money cash. Just, I don't know about you, but I'm not swimming in that kind of money. All right. Now, on the back, I want to show you another application of percent problems. It's what we call a percent change problem. And the percent change in an amount is precisely that. It's the percent, or the percentage an amount has either increased or decreased. So when we're looking for a percent change, it's by what percent has our amount increased or by what percent has our amount decreased over a period of time. Now, when you're calculating a percent increase, that's always going to calculate as a positive value. And when you calculate a percent decrease, it's going to calculate as a negative value. But either way, it represents a change. So the percentage that you actually calculate is going to be the percent change. Positive means it was an increase. Negative means it was a decrease. All right, so here's a formula to find our percent change. Is we take a new amount minus a starting amount, some initial or starting amount, and divide by that same initial amount. That fraction gets multiplied by 100, and that's going to give us our percent change. Okay, so let me show you how this works. For instance, in number 4, it says in 2018, the Diamondbacks won 93 games. And then a year later, the Diamondbacks won 85 games. Find the percent decrease in the number of games won by the D-backs from 2018 to 2019. So the percent decrease, that's what we're looking for here. So we want the new amount of wins, or that's like the most recent. So the new amount of wins, that's the more recent one, that's 85. So it's 85 wins. Minus the initial amount. Well, initially, the first amount of wins they had, that was 93. So 93 wins. And then we divide by that same initial amount, which is 93. And it should make sense. Sorry, let me try to draw a straight line there. That was terrible. 93 wins here. Okay, sometimes it's actually pretty easy to mix up the numbers to say maybe the 85 went second, the 93 went first, but if we're looking for a decrease, a percent decrease here, because obviously they decrease, it should make sense we have a larger number that we're taking away from a smaller number to make that negative happen. So then this amount is going to be multiplied by 100, and then we're going to get from the calculator our result. So we have 85, we're subtracting 93, we're dividing parentheses. We're dividing that whole thing by 93, and then we're going to multiply that result by 100, and then we end up with a negative 8.6-ish. So this is about, a negative 8.6. Again, negative because it was decreasing. So the percent decrease in wins is 8.6. Or, that sounds really funny to say it that way. Let's say it like this. There was an 8.6% decrease in wins. Okay, now I know we calculated it as a negative, but that negative translates to the word decrease. So you don't want to say a negative 8.6% decrease, because that would be like a double negative. You could also say there was a negative 8.6% change in wins, in which case the word decrease isn't in there with the negative, so you can say a negative percent change or just the value as a decrease. So either one of those would be acceptable, but you don't want to put the negative and the word decrease because it's sort of like a double negative, okay? So I think this one makes a little more sense as an answer, but either one would be okay. All right, let's try that again. So Cynthia went to a dealership to trade in her paid-off 2006 Toyota Corolla for a new car. The dealership gave her $3,000 for the car. Then they turned around and sold to another customer for $4,500. So by what percent did they mark up the price? So a percent markup or a percent markdown, that's a percent change. So that's like an economic word for percent change. But by what percent did they mark up the price? So we're looking for a percent increase here. So a markup is a percent increase. And a markdown would be a percent decrease. But same formula, all right? So we want to know it's the new amount. So the new amount is what they made the new customer pay. That's $4,500. So $4,500 minus the previous amount. That's what they gave Cynthia for the car. That was $3,000. And then we're going to divide by that same initial amount, which was $3,000. And that all gets multiplied by 100. So into the calculator we go. 4,500 minus 3,000. That entire quantity divided by 3,000. And then multiplied by 100. And that gives us 50. So this is exactly equal to 50. That means there was a 50% markup. That's ridiculous. Okay, there was a 50% markup on the car. And you could say also 50% increase in the price of the car as well. And to say a positive and an increase, a double positive is okay, because double positive is still positive. But we don't want a double negative to undo that negative. Alright, I got one last one to show you. It says, Michael bought a pair of jeans on clearance at Kohl's. I don't know about you, but I love me some Kohl's clearance. If the original price of the jeans was $39.99 and the clearance price he paid was $9.98, by what percent were the jeans marked down? So again, if they're marked down, that's going to be a synonym there. That's the economic way of saying percent decrease. Same formula. Okay, so we want the new price. The new price was $9.98. That's actually what Michael paid here. The previous, or the initial, make sure I'm consistent on my wording, the initial price of these jeans was $39.99. So $39.99. And again, I know this was marked down, so it makes sense for the larger number to be subtracted from the smaller number. And then on the bottom is that same initial $39.99. So you want to make sure that these two match, okay? And then that's going to be multiplied by 100 to give us our percent. So $9.98 minus $39.99, all of that divided by $39.99, multiplied by 100. we see this is about negative 75.04-ish. Okay, so we can say this two ways. The pants were marked down. They were marked down about 75%. Or you could say there was a percent change of negative 75%, but the negative again is implying that it's decreased. So the pants were marked down 75%. That's a pretty good discount on those jeans. $40, I don't know, that's a decent pair, or an okay price for a decent pair of jeans, but $9.98 for that same pair? Oh, it's a steal. I love clearance. Alright, so I hope that's good enough for you to get started on your practice. But if you run into anything you think you need some extra help with, then by all means reach out. Till next time, take care.